Welcome back. In our last lecture, we talked about our mission to build an automated device inventory system. Now, let's talk about why that mission is so incredibly important in today's world. I want you to imagine this scenario. It's your first day as a security analyst at a new company. You're excited, you're ready to go. Your manager gives you your login credentials, points you to a sea of dashboards, and says, "Welcome aboard. First things first, get a handle on what's on our network and let us know if you see anything strange." You open up the logs and it's overwhelming. There are tens of thousands of IP addresses, millions of events flying by every minute. Some devices are talking to the internet. Some are only talking to each other. Some are busy. Some are quiet. You're faced with the fundamental challenge of cybersecurity: the unknown network. Before you can protect anything, you have to know what it is. And in a huge dynamic environment, where do you even begin? Now, the traditional approach to this problem usually involves a combination of things. You might have a configuration management database or a CMDB, or more likely, there's a massive spreadsheet somewhere that someone tries to keep updated. It's a manual list of servers and workstations. You could also try to run network scans to see what ports are open, but these methods share the same critical flaws in a modern network. They are static. That spreadsheet is out of date the second you save it. A new virtual server gets spun up, an employee connects a new device, and your inventory is wrong. A network scan tells you that a server has port 80 open, but it doesn't tell you how it's using it. Is it a critical production web server or a developer's test machine? Its name might be prod web 01, but is it behaving like it? We need a better, more dynamic way. We need a system that understands devices by their behavior, not by a label in a spreadsheet. This is where machine learning comes in, and don't let the term intimidate you. For our purposes, think of machine learning as a powerful detective's assistant that is incredibly good at finding patterns in massive amounts of data, patterns that no human could ever hope to spot. In machine learning, there are two main approaches we should know about. First, there's supervised learning. This is like studying for a test with an answer key. You feed the machine thousands of examples that are already labeled. The classic example is email spam filtering. We show the machine 10,000 emails, and each one of those emails is labeled spam, and 10,000 emails labeled not spam. The machine learns the patterns associated with spam and can then apply those rules to new unlabeled emails. The key here is that you need good, clean, labeled data to start with. In our environment with network logs, it's not just having the logs. Each one of those logs must be labeled with the answer key if you're going to be using supervised learning. But what if we don't have an answer key? That's where unsupervised learning comes in, and that is the magic we'll be using in this course. This is like giving someone a giant, messy box of Legos and just saying, "Organize this." You haven't told them how. They'll naturally start creating piles based on similarities. All the red bricks here, all the square bricks there, all the little window pieces over here. They find the hidden structure in the data without any prior labels. Our unknown network is that messy box of Legos. We don't have labels. We can't tell the machine this is a workstation or this is a web server. Instead, we're going to use unsupervised learning to tell the machine, find the groups of devices that behave in similar ways. The machine will find the patterns, and then we, as the cyber detectives, will come in and label those groups. I want to point out when I had that aha moment about unsupervised learning. I've done this all through my schooling years when I went to science. That was all about classification. We look here, we see attributes that make up a bear. A bear is made up of attributes. An ostrich is made up of attributes. A salmon is made up of attributes. And we've put them in buckets. We have warm-blooded, cold-blooded, jointed legs, without legs, invertebrates, vertebrates, have a shell, have 6 legs, have pinchers, have no legs. All of these are attributes of things, and science has put them together into logical groups, and then we've given them their labels. But first, we group together like attributes. That's what we're going to be doing here with unsupervised learning. To do this, we need data, and a lot of it. And for that, we'll be using an amazing free resource from Splunk called the Boss of the Sock version 3 dataset, or BOTS v3. This isn't just a random collection of logs. It's an incredibly rich and realistic dataset generated from a simulated incident response competition. It contains everything you'd find in a real corporate network: Windows endpoint logs, firewall and web proxy traffic, server data, and much more. Essentially, BOTS v3 is our virtual corporate network. It's our digital crime scene. It's a safe, complex, and realistic playground where we can hone our machine learning skills without any risk to a live environment. Throughout this course, we'll be using this dataset as the source of truth for profiling our network. And the beauty is, you can download that dataset, and I have that dataset, and we're working with the same set of data, which should imply that we are going to get the same results. And that way you can follow along and feel confident that you are doing this correctly. So let's recap. The unknown network is a huge challenge because traditional methods are too slow and static. Unsupervised machine learning is the perfect tool for this job because it can discover the natural structure of our network based on device behavior without needing any pre-existing labels. And we'll be using the fantastic BOTS v3 dataset as our playground. Now that you understand the what and the why, it's time to get our hands dirty. In the very next lecture, our first hands-on lab, I will walk you step by step through setting up your Splunk environment, installing the machine learning toolkit, and loading our BOTS v3 data. Let's get building.